All right, let's do this. Hello everyone, April 22nd. Oh, this is a tradition, huh? Hard problems every day. Restore the array. A program was supposed to print an array of integers. The program forgot to print white spaces, and the array is printed as a string of digits s. And all we know is that all integers in the array were in the range 1 to k, and there are no leading zeros in the array. Given the string s and the integer k, return the number of the possible arrays that can be printed as s using the mentioned program. Since the answer may be large, we have the modulo. So I forgot. So we just need to. So the question is to enter spaces, right, in this, such that each value is smaller than k, or from 1 to k. So in this case, because of a bunch of zeros, so now we have a bunch of zeros you can only associate previously because there's no leading zero. So this is basically just one value and it's smaller, so that's good. This is maximum is 10, right? So the maximum we can get is 10, and then we have two leading zeros, so there's no way. For this, oh, damn. So yeah, most likely it's DP again. I mean, we probably can use the same idea, right? So what type of same idea? So we have 1, 3, 1, 7. Okay. We can say, what if we say that what we want to know is how many different ways in this range, right? So we can, yeah, let's just do the same type of DP as we did yesterday. Let's see if it works. Right? I have 0, 1, 2, 3. 0, 1, 2, 3. Right? So I say from this, right, how many ways? One way. Right? Now we say 1, 3. Well, 1, 3, we can say itself, okay? Right, that's 1. And we can say however many ways we have here. And then we can always add another 3, right? Okay. What else? And then you shall be able to say, if you contain these two. Anyway, this will be 2. Right, going to 3, 1. That will be 2. This is also be 2. Right? How about 3? We're looking at 1, 3, 1. So we can say, if I have 1 by itself, then we're looking at this 0, 1. So we have 2. Right? Whatever this, we can always add this. That's when this is using as by itself. Now, what if we combine these two? Then what we need is 0, 0. So that will be a 1. Right? We can do 1, 3, 1. Right? So it will be plus 1. And of course, we can also say all of these together. So that's another 1. So add them together is 4. Right? And how about 3, 1, 7? 3, 1, 7, same thing, right? Because 3, 1 is 1, 2, that's a 2, right? Plus 3 by itself, that's a 1, so that should be 4 as well. So now how about everybody together? And everybody together, we have a 7, and we have a 1, 3, 1. And 1, 3, 1 will give us 4, because that's 0 to 2, right? And then we can also say 1, 7. So I need 1, 3. What's 1, 3? That's 0, 1. That is a 2. Or we can do 3, 1, 7 together. Then we have a 1. That is a 1. So we have 1 plus 2 plus 4. And 1, 3, 1, 7 all together. That's another 1. So that gives us 8. And if you look at this, every time, right, we have ba, 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 ba. Every time we want to add a new one, we can say the new one and I want this. Or we can have these, then I need this. Or I say the last 3 together, then I have, what's this? Or the last 4 together, and then what's this? And of course, we can put all of them together, and what's this? And then we add them all together. That will be a certain position. So every time when we hit a value, it's just the sum of everybody previously, right? Yeah, we're at this, we want to get this position, we need to know this plus this plus this plus this. So if I already have all the sum, right? If I already have the sum, then I don't need. So let's do this one more time. Okay. 1, 3, 1, 7. Right. So 1, 7, we start with 1. Okay. And then we say we want to know 3. Then we say the previous one plus 1, 3 add together. So right, we have a 1, the previous plus 1, 3 add together. So that's 1. So this one shall be 2, right? But we're gonna combine them to become 3. So the next one, I instead of I to add a 3, right? So next one, this will become 3. Add them together plus 1 will be 4. So this I should do 7, right? So the next one shall be this is 7 plus 1. It shall be 8. So the overall will be 15 if I have more going on. Okay, how would you do this? So that would be 1. This is 0. Okay? 0 by itself, it's okay. 0 by itself is not okay. So I cannot say 0 and then whatever is period. That's not okay. Right? So all I can do, if it's 0, I have to go back to the previous one, the first one that is not 0. So I have to skip. Right? I have to skip. Hold on. How long is the whole thing? 10 to the 5th. How we handle 0? I need to find a previous that's not 0. Right? The previous one that's not 0. So the previous one that's not 0 is this position. Okay, so I have the previous one that's not 0. And that's already the front. So at this position, we only have 1 as well. But in your previous, then we should be 1 plus 1. That's not. Hold on. Oh, that's fine. Because every time, so I need to record also the first position that's not 0. But anyway, this position is 1, right? So overall, I can say, okay, currently it's 2, but this is 1. And next one is 0. So I need to look for the previous that's not 0. So these has to be connected, right? So now we have this. And then we say, okay, what's the previous one? There's no previous one. So we just say this is good, so that's 1. So overall shall be 3. Right? Because we basically we say we have 1, 0. Wait, why you do 3? What's this 3? Well, the 3 means if I go here, oh, but you cannot go here, so yeah, I should be fine. And this, again, look for the previous one. So this is still 1, and this will be 4. But these are, man, these are not right. But this is what I will get. That's a total. Yeah, because if you have 0, you cannot say I have the previous and I do 0. That's not right. You have to keep looking for the first one that's non-zero, right? The first one that's none of these can all be 0. It doesn't matter. The first one that's non-zero, I say this is a unit, right? And you need to know if this unit is good. And then, what if we have more zeros? Then you need to know the next one that's not 0, right? You need to know the next one that's not 0. So we basically say this is a unit, right? This is a unit. Then next unit will be this. Next unit is this. So basically I need to maintain an array, right? I need to maintain an array that tell me where are the non-zero positions. Okay, non-zero positions. Okay, that should be like a stack, right? Let me just I0, I1, I2, I3. These are the non-zero positions. So whenever I hit a 0, I look for the non-zero positions. And then I want to know the total number of, well, we're going to first check if this is valid. If this is smaller than k. If it is, then I can find the total number of combinations, total number of ways in everybody from front to this, right? From front to this position, everything. I need to know everything here. And then I go to the this, that I need to know everything here. But then that's maybe, you know what? That's fine because I can build the prefix sum based on this. Right? I just need to know the prefix sum of these things. The prefix sum of this. These are all non-zeros. Right? These are all non-zeros. Which means in this case, if we have 1, 0, 0, 0, this is the only thing that's non-zero. So at this position is 1. So the prefix sum is 1. Right? And this, I find the previous and previous is nothing. Right? We don't have anything. Therefore, the prefix sum does not increment. We don't have prefix sum. If prefix sum is an array, right? This array, we don't have any more. We just have this one because that's the first one. So for this, I'll look for the previous. This is the previous. And I find this is good. So that's a good, right? Then I need to look for if there is any previous thing here. And the answer is no, we don't have. We don't have because the index, that's the only index. Previous is nothing, so this has to be by itself. I mean, that's good, that's a 1, right? But prefix sum must be recorded at the position of non-zero ones. So that's why this is a 1. We don't increment this. This is a 1, this is a 1, it's always a 1. So let's go back to 1317, right? So for 1317, I say this is the array of indices that's non-zero. So 0 is non-zero. And then we can say the pre-sum. These two shall correspond to each other. At this position, will be 1. Okay, next one is 3. I don't care. I just look for the previous non-zero, and I would look at this is 0. Okay, so I say from 0 to this, how big it is. Oh, how big? I need to make sure that it's, dude, can we need to int it? Huh. No, we don't have to int it. We just times 10 plus this. Okay, times 10 plus this, so we know what its value. That's not true. That's not true. Because I need to know from this to this. Holy moly. I mean, we can compare directly, right? Yeah, we can compare it to the k directly. Anyway, we just say, okay, this is now 1, 3. That's definitely smaller than k. Okay. That's actually not right. I want to know, because this is not 0, so it is not 0, so it can work by itself. Okay, this is not 0, so it can work by itself. Okay, it can work by itself. But I cannot know everything, right? Because it needs to know, it cannot go all the way back. It has to go back to a certain point, right? K is 10 to the 9th. So I need to go forward 9 times. Wait, do you need to go forward 9 times? No, you don't go forward 9 times. You do go forward 9 times here. Okay? So you go forward and see if, like, how much you can get. Because you do this by yourself, and you can do 2, you can do 3, you can do 4, and at a certain point, like before, right before you break, you're bigger than the k, right? You say you can all go all the way there, right? So if you have something, 3, you can say, this is good, this is good, this is good, but this is bad. Okay, so this is the most you can go to. This is the most you can go to. Therefore, this I can just loop. And I can, damn, times 10 plus this. That's the times 100 plus this. But anyway, that's trivial. So we find this is the largest we can go, all right? Therefore, I need to know the total number of ways. The total number of ways. Wait, hold on. Is that right? The total number of ways in between. The total number of ways in between. I can know the total number of ways in between. That's fine. I know how many. And I know they can always go with 3. Yeah, what if you cannot go to the front? What if you cannot go to the front? I'll do one more time. Okay, so we have some stuff, right? We have some values. Doesn't matter. We have some values, large S. And let's say k is equal to 1000. Okay, now let's do k equals 999. So make sure it's only 3 digits. Right, so 4 digits will never work. So what do we want? Right, what do we want? Let's say we want to know, let's say we know the total number of ways to break it down. Let's say I have the total number of ways to break it down in here, and in here, in here, and in here. I know the total number of ways of breaking them down. And these actually don't matter. I only need to know this, right? I know the total number of ways to break it down in here. I have so many. And then this one comes in. And let's say it's not a 0. Okay? If it's not a 0, then we're good. Then I have the total number of ways of this. Breaking down. Add this, add to this, right? Because all of this, the total number of ways, is satisfying k. So I have this, let's say, we want to know dpi. So we have dpi I minus 1, right? That's good. And then I say, how about I combine these two together, right? And combine these two together, I need to know whether it's good. And I say, yep, it's good. Or if it's 0, then I just have to keep moving forward to go for the first one that's non-zero. All right, let's just say this is 0. And we cannot do this. So look for the previous one that's non-zero. Say this is non-zero. Then we look at this. Okay, this is still good. Then this need to plus dp. That's not I minus 1. That should be I minus 2. All right? I minus 2. And then look previously, and this, boom, now it break because this is larger than k. So this position is going to be I minus 1 plus I minus I minus 1. Yeah. And I minus 1, I minus 2. Wait, hold on. That's not right. This, I can take this I minus 1, right? And I say I want to do this. This is I minus 1, I minus 2. No, that's actually not right. I minus 3, my bad. It should be I minus 3. This is 3. Because this doesn't work, right? This will be I minus 2, but I can only do this. And then previous one will be I minus 3. So dp of this plus I minus 3. So what you're saying is for each new position, right, dpi shall equal to dp if I is not equal to, if dpi, no, if si is not equal to 0, so that should be dpi minus 1 plus dp something, right? Just we have to go to the previous non-zero. So I do still need a non-zero array, right? The non-zero indices. Therefore, whenever I happen, the current I, if the current I is not equal to 0, this one will definitely work, right? This one will definitely work. We have to do I minus 1 because this current one can always be by itself. Unless the k is so small that we cannot do that, right? We'll do I minus 1. But the next one, I need to see the previous indices, right? Previous indices. So I will combine with the previous index. So I'll combine the previous index and the current I to form a new value. That could be I minus 1 or could be something else. And now when I form that, I check if it's like how big is this to k, right? How big is this to k? Do we have a better way to check? I'm not sure. I mean, we can int. We can always int it, right? If it's good, right? If this is good, then we do dp this. dp this one minus 1. Okay. And then we keep going until it's covered. And because we have this requirement, so we won't go all the way down. So we'll go a few down, and then, you know, it's no good, and then that's it. Okay. So you're saying if we do 1000, it will work as well. Because I'll record 1, and this DP will only have, this array only have 0. Oh, this is a 0. We haven't considered that yet. So now we consider if SI is 0. If SI is equal to 0, then I cannot do this, right? Then we say DPI shall equal to, we need to find the previous one. So we directly go into this mode, the second mode, right? We need to check the previous one that's not, right? That's not 0. And then after we check that, we check if the whole value is within K. If it's within K, then we do the DP that thing minus 1, right? And that will be a 1. So the DP, I think, shall have a dummy value at 0. DP 0 shall be 1. So if we go outside, it can do 1. Okay, so we have a lot of moving pieces. A lot of moving pieces. Let's give this a shot. Lots of moving pieces. So I need to know the non-zeros. Okay, this non-zeros. And we can do s equals s dot left strip. Okay, we can get rid of all the leading zeros. And then what? DP equals 1. Okay. Then we say for I in range len s. Okay, I in range len s. So now I'm looking at this. Then I need to know whenever I see my current value, I need to check, right? Let's say if SI is equal to 0, okay? Let's just say if SI is equal to 0. Actually, it's not going to happen at first. Yeah, let's say it's not equal to 0. Okay, if current one not equal to 0, right? Then I need to check if it's larger than K, if it's good to K, right? This is I. What do I do? What do I do? Okay, we can say if int si is j. Okay, let's say j is equal to I, while int sj to I, if that is smaller or equal to k. Alright, if that's smaller or equal to k, if that's smaller or equal to k, so we have this range smaller or equal to k, then I can say dpi. Ooh, that's actually not right. Let's say len s plus 1. And dp0 is going to be equal to 1. This should be I plus 1, right? So we say this shall plus equal to dp j minus 1. Okay? And then what? And then j shall equal to non-zeros p. Okay? So we can say p is equal to len non-zeros minus 1. Okay, so we do this. J minus 1, which is just I minus 1. Okay. And then j will equal to non-zeros. The previous non-zeros. That's fine. And then p minus equal 1. Right, so our p is largely equal to 0 and p minus equal 1. And then j, we have a new value. Then we check again. If it's good, then I do this, and blah, blah, blah. At a certain point, either this fail or this fail, right? Then we come out. When we come out, then we say non-zeros dot append I. That's the new non-zero. Does that make sense? No, that does not make sense because this has to be j. Basically, j plus 1 minus 1. Okay. Else, if the current is 0, then I feel like I'm making this more complicated than it should be. Yeah, I think it's making it more complicated than it should be. So, of course, wait, hold on. We still have to check. Yeah, we still have to check. Okay, let's make it easier. So if int si, that's all we want to know, is smaller or equal to k, then dp I plus 1 shall plus equal to, well, equal to dp I, right? Yep. Okay, hold on.
Can I drink?
And look at that. 45.
First of all.
Alright, let's get back to it. Where are we? I say if it's smaller than k, then we'll do this. And then we'll basically just non-zero, right? You can say for j in non-zero and we say if int s j to this smaller than k dpi plus 1 so plus equal to dp j plus 1 minus 1, right? Else don't break. Right, so that's that. Oh, and non-zero start append. Oh, if it's smaller than k, what if it's larger than k? If it's larger than k, then we basically have no way. So we can say this dot append I, else I'll just break. Yeah, if its individual is bigger, then there's just no way. Then we say else. Right, else is it's equal to 0, which means this will always work. So we directly do this. This one is not true. We directly do this for j, for the non-zeros. And we try to see if it fits. If it fails, right, if it's smaller than k, if it's smaller than k, then we do this, right? If it's larger than k, then we exit. We don't try it anymore. Is that good enough? And at the end, we will return dp minus 1, right? All right, let me think. What if the first one is larger than k? Well, if the first one is larger than k, then there's actually no point going forward. Maybe we still has point going forward. If the first one is too big, and it's fine. It will handle. Yeah, because you never know if it's the first one or second one. Now we can say if it's the first one or second one. We'll give this a shot. It feels... I don't feel as well as yesterday, but can give it a shot. Sayochi, 2008. SK. Yeah, they are right, but I have... Let's try 10, 5, 2, 1, 100, 1,000, 10,000. I am surprised that they're all correct. What else can you throw at it? What else can I throw at it? I can throw... definitely... How about this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 5, 6, right? And then 1, 2, 3, 4, 5, 6. What does this do? This doesn't do anything. Well, I mean, this just means anything goes. Zeros. You have not considered zeros. Okay, so now we have some zeros. And then, yeah, let's try these. 2, 3, up to 10, 100, 1,000, maybe 10,000. Okay, let's try these. I have more confidence. All right, let's give this a shot. Oh, I did not mod. Darn it. You need to mod. We mod here then. I'll see if that works. Yep. I think it's just a mod. No, my timeout. Oof. Damn. Maybe we mod inside. Yeah, we can try. Most likely it is not. But Lordy. Holy crap. No. I think we need early exit. Yeah, this is not working. Okay, so the general idea is right, but what? Because you're just adding them together, right? So you should consider doing prefix sum. Yeah, I think we should do prefix sum on this. Prefix sum based on the non-zeros, right? A prefix sum based on non-zeros. Therefore, all we need to find out is to which position? To which position we will. I mean, we can figure that out. To which position we can figure that out. This is fine, right? Just this part. These two are exactly the same, and we shall be able to compute this by prefix sum. Okay, so all we need to know is for all of these, which one? Well, yeah, I can know that. I just need a prefix sum. So I have a non-zero and a p sum. Okay. A p sum, we can start with 0. And then we have a dp, right? And then we can do this, right? And then this will be smarter, okay? So we know the number of digits that k is. We know the number of digits of k, right? Number of digits of k. Then we can say here k digits len strk. Okay, now we know k the digits. So now what we want to say is find j, right, such that sj 2i plus 1 is the largest integer, right? Is the largest integer in S that is smaller than k. That is not bigger than k. Right, this is what we need. So we know the total digits is k digits, right? Therefore, we are at the ith digit. So we move forward k digits. Oh, how are we going to handle this? We move forward k digits. Hold on, what we're saying is I am currently If I am at this position and say this is I, right? And I know, let's say k digits is equal to 3, right? So I need to move forward 1, 2. So I minus k digits, right? Minus 1. I minus 1 minus 2. So this shall be j. Then we just compare sj j to I plus 1 and k. We compare these two, right? This, is it smaller or equal to k, right? Is that right? If it's right, if it's correct, then all we need to do is to find what? To find a prefix sum, right? Because we want to know, basically, because I is here, want to know the sum of this, the dp value of this, plus dp value of this. So it's the dp value of all the way to the prefix sum of all the way to this minus the prefix sum all the way to this. Right? So if we want to translate to this, j shall equal to I minus k digits minus 1. Alright? Then we say if int s j to I plus 1 is smaller or equal to k. Right? If that is smaller or equal to k, then what? Then what? Oh, what if it's a 0? Dude, it cannot be 0. If a j is a 0, then that's no good. Right? If a j is 0, if j is 0, oh. Oof. If j is 0, dude, I need a binary search? The non-zero? Come on, don't do this to me. You want me to binary search? But I need to know that I need to know. Hold on. Let me think again. Yeah, this j. You know what? I might need to have binary search. Oh God. Right? So that's a j. That's a temp. Okay, I'm not sure if it's right. Then I can binary search this temp inside the non-zeros. Okay? I binary search this temp inside the non-zeros. What will happen? Well, it will tell me if it's if the temp points to 0, then we'll get that one, right? The right side one. That will be a j. If it's equal, right? If it's equal, then it will still go this. Then I need to go to the previous one. Therefore, I think I should use bisect left. Right? I should use bisect left. And of course, this is actually, we need to go the maximum, right? That cannot be smaller than 0. So we do this. And then I say index equal to bisect left, non-zeros, and temp. What does this give us? So this gives us the bisect, right? And the binary search, which index in non-zeros. We're pointing to the non-zero indices, the closest non-zero indices that satisfy k digits. Then what? Then we say if it's equal, then it will actually insert previously, so that would be index, right? If it's equal, I just want index. If it's not equal, it will be in between, which that's also correct. So j shall equal to non-zeros index, which I think I probably can just do this. Okay, get the index and then we get a j. Now I know j is not a 0. So I can do this, right? We see if it's smaller or equal to k. If it is smaller or equal to k, right? If it is smaller equal to k, then what do we do? If it's smaller equal to k, then we can say dpi plus 1 shall equal to something mod plus what? P sum something minus P sum something. What's this? This shall be, oh god, that's just non-zeros minus 1, right? Oh. Yeah. I think so. That shall just be non-zero minus 1. Because the prefix sum is only associated with non-zeros. So you're telling me that this should be minus 1. Minus what? What's this? I think that should be index. Because what index represents, we say this is good. So that should be index minus 1. Right? Otherwise, if it's too big, then I think you just do index. Boy, this looks convoluted. Is that right? The prefix sum is the non-zero, right? And now you're hitting a new non-zero. And you do it by itself, which is fine. And then you look for the, that's the previous non-zero, right? And you look for this, okay? Which will make it work. And we say if this does make it work, right? It might be these two are the same. What if these two are the same? Then it's fine. P sum minus this minus 1, that's fine. If this is still too big, then that will become 0. So maybe, yeah, maybe this is a way. Right, after that, non-zero, I'll have to increment the non-zero, and P sum shall dot append. But the P sum has an issue, because P sum is 1 bigger than this. God. And this should be this, and this should be plus 1. Oh my god. Okay, P sum dot append. P sum minus 1 plus dp I plus 1. Because the current is now equal to 0. And of course, whenever it becomes larger, then we just break. Else. Holy crap. So else, I think, is the same. Let's just put this one here. Else. The current is 0. Okay? Then I do the same thing. We're trying to find the index in non-zero that's closest. Then we get the j. Then we check. Right? We check. And we check if it's smaller than k, Then we do this. Actually, I don't have to add. I think all I need to do is just do this. Maybe I should mod here as well. Let's mod here as well. Right, then we will minus probably we don't need to mod. Otherwise, we'll do this. Is that right? Not sure. Try it. Oof. God. Oh. That's interesting. The first one got wrong. Okay. Nowhere. Let's see. There's one. Non-zero is empty. You gotta be kidding me. Non-zero is empty. Non-zero is empty. Then I try it. Then how can I even try it? Huh? What's index? Oh, empty I can. I can do empty. Yeah, I can do empty. Oh, gosh. So if it's not empty, right? If it's not empty. Okay, if it's not empty. Okay, so if non-zeros, then we do all this. This is fine because we already have non-zero. This is just the first one. If non-zeros, we try to find this. Otherwise, we do this. Jeez. Nope. Nope. How? What do we have? Let's say I, non-zero. 0, 1, 2. 0, 1, 2. And 2. Oh, it's too big. It's too big. What does that mean? That means... Oh, God. That means bad, right? That means bad. So, we shall say if index is smaller than len non-zeros. All right, then we do this. Okay. I just feel like you're gluing things together. Now this is a real issue. 13. Yeah, it should be 8 instead of 13. Maybe I don't do this? No, I have to. Interesting. Okay, let's see. The last one. 7 comes in. Okay. All right. 1, 3, 1, 7. 7 comes in. I already have 5. Okay. I already have 5. Is this supposed to be 5? I don't think this is supposed to be 5. Wait, hold on. What's the p sum? P sum is even bigger. I do need it. But that should be 3 plus 5. So I do have 5. Okay, I do have 5. And non-zero is right. Index was I. 0, 1, 2, 3. I is 3. 3 minus k digits is 3. So 3 minus 2 is going to be 1. So I can go to 1. That's not right. 0, 1, 2, 3. I'm at this position. Oh, it's 4. My bad. It's 4. 4 minus 1 is 3. So 3 minus 0. So index. Oh, this is 0. So non-zeros. Oh, God. I need non-zero as well. Where's my print? Give me non-zero. Let's do it at the front. Non-zeros. Okay. Non-zeros. So now I have 0. 0 and a 0, so index is 0. So j is equal to 0, right? Now we say from 0 to 3 plus 1, 1, 3, 1, 7 is smaller. That is correct. Then I say this plus p sum. What's p sum? P sum is this. P sum minus 1. Ooh, that's 8. That is 8. P sum minus 1, which is the total of everything added together. Everything added together. Have issue. What's p sum? Prefix sum is because when I'm at this position, right? I'm at this position, and then I need to yeah, index is non-zero because p sum is larger than non-zero. So if a non-zero is at a 0 position, right? And for p sum, hold on. Let me think again. I'm at this, right? And I find out this is the best position, okay? Then I need to know, what I need to know is this plus this plus this plus this, right? So I need to know this, which is p sum minus 1. That is correct, right? P sum minus 1. Which means in total, because I have this much added together, plus this much added together, plus this much added together. Yeah, but you are duplicating the things. I am duplicating the things. let me think again. It's already added. That's why it's not right. I still think maybe this is not necessary. I still think this is not necessary. But the thing is, when you do this, everything becomes 0. Why? Because when 3 comes in, when 3 comes in, oh, I missed her. When 3 comes in, right? Non-zero. Wait, hold on. DP. No, when 1 comes in. Oof. The first one. Okay. Okie dokie. Okay. Let's do it this way. Okay. So DP is the same length. If S0 smaller equal to K, and DP0 equal to 1. Else return 0. That I can do. Or I can just say if this is larger than K, then return 0. Right. Otherwise, DP0 is this. Then I can go from 1 to the end. Now the only one with different size is just going to be the prefix sum. Okay, then I can handle this. Again, this, if this is smaller. I don't even need to break. I can just return, but that's fine if it's smaller, right? And then this is all fine. And then I can say this is just DPI. DPI and DPI. Still not working. Why? Now I can say 3 comes in, right? 3 is smaller than, and non-zero, we have non-zero. Oh, non-zero. Damn. Then pre-sum can be 1. No. Pre-sum need to be like this. Then because pre-sum, I'll have to handle index. Okay. Okay, let's analyze again. Apparently it's not right. Now, first come in is this, right? Now we have 3. I have 3. So 3 comes in this. So 3. I is 1. Hold on. Let's handle everything. So dp, and then let's do I. Okay, I is 1. 1 minus k digit is 4. So that will be 0. So index will be non-zero. Right, this is non-zero, define 0. Fine, j equal to 0. And then from 0 to this is smaller. So dpi equals p sum minus 1. P sum minus 1 is 1. Minus p sum index is 0, so that will be 1. So that's why it's a 1. Done. The next one, next one, dp is this. P sum is this. Non-zero is this. I is 2. 2 is 1, right? Again, this is good. So this also go back to 0, right? So now what we have is p sum minus 1. P sum minus 1 is 2, right? 2 minus 0. So that will be 2. Is that 2? Is that 2? Two shall be 4. Shall be 4. This one shall be 4. Shall be this position, shall be this value. What? Oh yeah, it is. Right? It is. So isn't that should be dp? dp is just no. Hold on. Let me think. 1, 2, 3, right? 4. Damn, it is 4. Why would you say 2? Okay, non-zero. P sum. dp. All right, that's it. We don't have these 3. dp. Yeah. Okay. Now we have 3. Okay. 3 comes in. 3 is not equal to 0. All right. So now we look at 3. 3 is not equal to 0, and then the best is going to be 0. So the 1, 3 is good. So non-zero now is 0, 1. dp, what is dp? So for 3, I say I need to do this plus whatever at the front. And then this is just going to be this. So for 3, it's going to be right, 3. Hold on. 3 by itself is going to be everything up to here. 3 and this and everything up to here, right? So that's 1. So up to 3, that's not 1, that's actually 2. Oh, that's actually 2, I forgot. Because this is good. So is the p sum, right? P sum is 1, but I need to add this is good. And what does that mean? That means that means p sum shall be 1, 1. So the index is this thing, right? Index is minus 1. Index is this. No. Again, come again. Right? I say 1, 2, 3. This is good, right? So I shall have the dp here, right? Plus dp here. I should have a dp position here and dp position here. And this dp position is always 1. Right, which means if we want to go prefix, if this one on the prefix is going to be everything adding to this minus everything adding to this. That's why it's only 1. That's true, but you just have to add another one by itself. The whole thing by itself. Hold on, let me think one more time. So you're saying the p sum shall start with 1 and because dp, the first one is 1, which means p sum shall already be 2 at the first position. And that's not right. That's not right. What I'm saying is dp disposition is 1. dp disposition is also 1. Therefore, p sum is 1 and 2. And when I have this position, I find non-zero is this, right? Then I have dp this is going to be 2 minus, no, dp this shall be 0. Wait, doesn't make any sense. Doesn't make any sense. Doesn't make any sense. Right? So this, I find so I need to know what is the dp here, right? Because I want to do this by itself, then I need to know the dp of this. I need these two, I need to know dp this, right? I need this, I need to know dp this. So this plus this plus this, which is the pre-sum this minus the pre-sum this, right? Yeah, that's like duh. And now I have 1 and 3. There's nothing in front. So I need to know the dp. I have a dp this, so I need to know I have the pre-sum this minus the pre-sum empty, right? Pre-sum empty. And pre-sum this is only 1, right? It's 1. And pre-sum empty. So pre-sum empty, this one should be minus 1. So you're telling me that the pre-sum shall not be this. Okay? You're telling me the pre-sum shall be minus 1 at the front. And the first position is going to be 1. Now if that's the case, right? If that's the case, and now we're looking at this position, I know the furthest I go is this one, right? So I do dp minus 1 minus the index minus 1. So 1, so that will be 2. So now I get 2. And this will be 3. Okay, so now if I keep going forward, now we have a new is 1. So non-zero will become 2, right? And then I find 4 digits, so it's still landing 0. Okay, and still landing 0. Now what I need to do is this 3, right? P-sum minus 1 minus index, so that'll be 4. And this will be 7. Now look at 7, right? It's 0, 1, 2, 3. That doesn't matter. Now we look at dp. So 7, we go to 0, that's still fit, right? So we want to know there's a dp minus 1, minus, then it becomes 8. And this whole thing is actually 15 at the end. Therefore, what I'm trying to say is p-sum shall be minus 1. 1. Alright? Then we start from 1 to the end. If it's not this, we just break. That's true. If this, we get this, right? J, we got index. And then if this is smaller or equal to k, then we do index. Otherwise, we do this. So this will be correct. But hold your horses. We need to check the other two. Now, the first one is not right. Lord. So minus 1, 1 is right? And then we're looking at this 0. So this 0, I'll look previously. It does give me 2. Something is not right here. So now I'm a 0, right? I am a 0. So I look for the previous which find index is 0. Okay, that's fine. We find the index is 0. Now what I need to know is j. So this j is 0, right? J is 0. So from 0 to this, it was good, right? It was good. That's not right. It's not p sum minus 1. No, that's not p sum minus 1. This is not p sum minus 1. That's not correct. That shall be p sum, because I find the index, right? So we say from an index to this. Okay, so this is good. So I need to go for, this is the largest, right? This is the largest. Yeah, this is the largest. So I also need to find the smallest, right? The smallest. Therefore, I need 2 indices, right? So index L and the index R. Well, you don't need this. It's just non-zero minus 1. Right? Non-zero minus 1. Minus 1. Because this is not minus 1. Because minus 1 is the last one, is considering the current one can be formed by itself. But the current one cannot be formed by itself. So I need to go minus 2. Right? Because the last non-zero index, right? We cannot, because k, this si is a 0. So I must form with the last index in the non-zero. And if I form with the last index of non-zero, the p sum has to be minus 2. Gaudy. Oh, that should be index. Okay. Oh my god. Okay, calm down. now I find 1, 0, right? I find 1, 0. Then I need to know 1, 0. Oh, maybe I do it this way. Okay, so I find the index, right? I find the j. If it's smaller than, then I need to do, right? So from j to this is good, right? So we need to say if index is, if this is the largest one, right? So if index is equal to 0, okay? If index is equal to 0, that means we're at the beginning, right? We're at the non-zero, at the first non-zero index, which means the whole thing is good, right? The whole thing is good. Now, if the whole thing is good, then that's an extra one. Because I say add this, add this, add this, add this, add this, then I need to add the total. So if index is 0, right? Because I need to do index minus 1, right? Basically, that's the case. I do index minus 1. This I need to do index. But index is 0, so I cannot do index minus 1. Therefore, I shall say in this case, say if index is larger than 0, else it's going to be 1. In this case, it'll be the same, right? We say right, we have 1, 0, and we just need to go, so that's index. Index is, okay, so that is the biggest that we can go, right? That's the biggest that we can go. So now what? Now I need to also find the smallest they can go. Now the smallest they can go is, right, len non-zeros minus 1. That's the smallest they can go, right? Then it's just the smallest they can go minus the biggest they can go, right? And if the biggest they can go is a 0, no, else it should be 0. Right? And this is the same. Now this should be minus 2. Wait, really? Minus 2? You don't have minus 2. Biggest they can go and the smallest they can go, right? And if they're not the same, then we do this minus this. Okay? If they are the same, what if they are the same? Then I think I just assign it to 1. Alright? if the biggest it can go and the smallest it can go are the same, right? Are the same. If they're not the same, then we can say it'll be this, right, plus hold on. If this is the smallest they can go, this is the biggest they can go, right? Then I can say this, then everything of this, and this is the largest they can go, then everything of this. So it's this minus 1, and the smallest also minus 1, right? So the smallest they can go, minus 1. And what if the biggest and the smallest are the same? The biggest they can go and smallest they can go, so this should be this minus 1. What if it doesn't have minus 1? Then just 1. I don't like this logic. Because I feel the two logics shall be the same. But it's not the same at the moment. Right? We find the index. Yeah, it's smaller than k. And this is the largest we can go, right? Shall be p sum minus 2, because it might not have minus 2. Because minus 1 is definitely, yeah, so we have to consider that. Why is it so complicated? Why is it so complicated? Okay, we just say if this is smaller than k, okay? Okay, let's do index left. Okay, that's index left. Okay, and then we can have index right shall equal to non-zeros. Line non-zeros. We can say if index left is equal to index right, which means they all converge in one position, then we say dpi shall equal 1. No, does not equal 1. That shall equal 2, because we just say we can only extend to the same position, right? We can only extend to the same position, right? Then we shall say shall equal to p sum index L minus 1 if index L is larger than 0, right? Else 1. Okay, else Now else is considering that index left will be smaller than index right. Okay, it will be smaller. So now there is a gap in between. Right, now elif, right, index L is smaller than. Now we can do this. Now we say from J to this is smaller than K. Okay, this is smaller than K. If it is smaller than K, then we can say that shall equal to index right index right p sum index right I'm gonna say -1. Okay, index right -1. So like we take this by itself, so index right -1 minus index left -1. If index left is larger than 0, else 0. Else index right -1 minus index left minus index left. This won't work. Okay, so in this case, I'll just say this is equal to this. And this will equal to this. And too complicated. Oh my god. Now this one's not right. Jesus. We already said it shall be 3. dp should be 4. And dp is not 4. 1, 2, 4. I is 3. dp is, yeah, dp should be 1, 2, 4. dp should be 1, 2, 4. P sum -1. P sum -1 1. Maybe this should be -1. Maybe this should also be -1. This feels wrong. This feels so wrong. Like these two cannot match each other. This feels so wrong. Nope. Then it's not right. Oh God. Oh. Alright, we have this. This is correct. I just need to fix this, right? All I need to do is fix this. Now how come I cannot fix this? Let's get this back, okay? Let's get this thing back. It's unbelievable that like I just simply cannot do it. Let's get everything back. We have it, right? The only thing we need to handle is to make this part more efficient. That's it. That's all we need to do to make this part more efficient. And this part is the same as this part. These two parts are exactly the same. So that's why I just don't understand. How come we cannot just do it? Right? Just for this, if this is smaller, then you just keep adding, keep adding, keep adding. Every single one, right? And now what I say is we can look for, so like if I have a, this non-zero, and I have a prefix, right? A prefix of non-zero. Pre-sum, right? If I have a pre-sum, and let's start with 0. If I have a pre-sum non-zero, and every time non-zero do this, we say pre-sum dot append. Right? I just add to it. Okay. And then, instead of going through them one by one, we can actually look at pre-sum. I think the pre-sum will be correct. Yeah, pre-sum will be correct. So, instead of going through them, right, we can actually see index, right, shall be bisect left non-zeros I minus k digit or plus 1. I have the index. Okay. Now I have the index. Then what? Then we say if st now int s non-zero's index. Right, f non-zeros. Non-zero's index, that's a j to I plus 1. Right, if this is smaller or equal to k, then I'll say dp plus 1 plus equal to what? For each one, we'll form this together, right? I will form this together. I need to know dpj. dpj. Actually, j minus that's actually this is actually j minus 1, right? So when they form together, it should be this. And then this together should be this. Go all the way to index. Index give me the j. Okay, so go all the way to this is index. So this towards the end is good. I mean, this can get together, right? So we should do index minus 1. Right? Should do index minus 1. And this can form together, right? So that should be presum. This is presum minus 1. But we should not do presum minus 1. Because I need this as a presum minus 2. Right? Presum minus 2. Because I want this plus to this one. Right? This plus this plus this plus this. This is presum minus 1, presum minus 2. Right? So I think it's presum minus 2 minus what? Presum, right, index. It shall be index we do index, right? This from index to this, and j to this is fine, right? This is fine. So we should be adding this, right? We should add this. So we need to minus 2 plus 1. Else, if this is too big, then we index plus 1. So index plus 1 minus 1. So it's index. Let me think again. Index, right? This is the index. And then index is the maximum we can try, and it's too big, right? So I need to minus. So I will do index plus 1. So it shall be index. When you include index. So we do index minus 1, index minus plus 1. So that will be this. Right? And since this is exactly the same, I think I can just copy and paste this whole thing. Not sure, but I can give it a shot. Oh my god, that's not right. Oh, dear lord, this prefix sum stuff is just so annoying. IDP non-zero pre-sum. And then W1, that's fine, right? So that's 3 comes in. 3 comes in. So dp shall equal to, right? So this will become I is 1. That's not right. It's so simple, you just keep adding. God. What the hell? After this is done, pre-sum. Let's say we start with 0, right? Now it's 1. dp is just 1. Now 3 comes in, right? 3 comes in, non-zero will be 0, 1. And then I need to find, because 4 digit, 4 minus 1, so we find index, right? From this index is 0. So index 0, I find 1, right? So what I need, so I already say this by itself. So the dp now is already 1, because I know I'll do this. And then I say, if I combine with this, right? If I combine with this, right? If I combine with this, then I need to know what's the maximum. What's the maximum? If I combine with this, so I combine with this, what's the p sum of this thing here, right here? What's the p sum of this? Right? Because that's index is 0. Index is 0. Yeah, so the p sum is -1 and -2. So p sum is this position. It's this. Minus, this is the, right? And this -1. Index -1. So it's also this one. Yeah, that's the issue. So what I think is, if we go to 0, yeah, what if we don't include this, right? So p sum, the first one is 1. It's all the way to this is 1, right? And now I'm going to 3, and then we find the maximum we can get, right? The maximum we can get is position index equal to 0. The maximum we can get to the left, and the smallest we can get to the left is index is also equal to 0. So these two are the same, right? Basically we say the max we can get something 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 3. The max we can get, if we keep going left, that'll be too much. And the smallest we can get, I'd say maybe these are all zeros, right? And the smallest we can get is also this. So that's the only thing, right? Then we need to know on this side, what is it, right? So that we can say, when this happens, it's just going to be 1, right? Which is going to be 1. So the pre-sum is going to be 2. So if these two overlap, right, then if they do not overlap, right, we have the max we can get is here, smallest we can get is here, and then we have bunch whatever in the front. Then we can say the total should be this, right? We can form this together, can form this together, can form this together. So be this plus this plus this, right? So it should be this minus this, Yeah, because this is fine. Plus this thing. So this plus this plus this. Right? So that's the index right. Index right minus 1. Right? This is index left minus 2. And of course, if we don't have minus 2, let's say this is the first one. So we don't have. So it shall be this. That just shall be this. So what you're saying is, yeah, this by itself. Then we have index left, and then we have index right. Index right shall be len non-zeros minus 1, right? And then let's say everybody is just, that should be 0. Alright, that should be 1. Right, and this should be 1. And then so we go 1 to the end. Okay? Then we don't need to do this because there will always be a non-zero. And then we have a left and right. And we say if index left is equal to index right, then dpi plus 1 plus equal to free sum index left minus 1 if index left is larger than 0, right? Else that's just 1. Well, of course this has to be first, right? If it's smaller or equal to k, then we say if that's the case, then we do this. Else, if that's not the case, then it shall equal to index right minus 1, right? Minus index left minus 2, right? Right minus 1, because we start from here, we add this, and here we add this. This is good, and this is also good. We need to add this. So yes, this add all the way add to this thing. So it should be minus 2, right? Should be left minus 2 if index left is larger than 1, right? Else 0. Else, if this is larger than k, then, well, we might actually do it this way. We say if this is larger than k, then index left plus equal 1, right? Then we do this, right? Then we do everything. And here is the same, right? We get this whole stuff. We get this whole stuff. Is this one right? Oh God. Of course it's not right. I shall equal to I minus 1. Yeah, these should be I. So fine, this is not fine. This is not fine. Ugh, that's still not right. Why? Okay, let's see what's index left and what's index right. This 2 is correct. Okay, now we are at position 2. Okay. It shall be 4. Alright, so okay, so DPI, yeah, that's already 2, so that's good. DPI is already 2. And then these are not the same. Actually, I don't need this. These are not the same. So DPI shall equal to index right pre-sum. What's the pre-sum? Pre-sum. Is this. Pre-sum index I minus 1. 1. 1. We're here, right? Pre-sum is 1. No, this is 2. This is the pre-sum, should be 1, 3. Right, that's the pre-sum. Now I'm here, right? I'm 1. And then I get this. So index is 0. Index left is 0. Index right is 1. Okay? Then what? Then I say, I have this by itself. I have this by itself. I have this by itself. Right, I did this, so I have this by itself. I have this by itself. So I already have a 2. So 1, 2, I already have a 2 temporarily. I already have a 2 because this is a 2. Then I say I want to know, right, these two together. Right, these two together shall do prefix. That shall do pre-sum 0. Right? So I pre-sum 0. And all of these together. That should be pre-sum minus 1. But we don't have pre-sum minus 1. Therefore, what we have is this plus 1, right? Plus 1. Okay, but I'm missing 1, which is the whole thing, right? Which is the whole thing. Which also means if we get to well, that's why it should be minus 1, right? That's why this I say, if this is larger than 0, then yeah, if it's smaller, if this is equal to 0, index left equal to 0, which means the whole thing is good. Now, if the whole thing is good, right? If the whole thing is good, then yeah, this is larger than 1. If index is equal to 0, right? Larger than 1, like 2. What if this is equal to 1? Index L is equal to 1, because I do index L minus 2. Index L is here, right? I want to add this. Now I want to know this, I need to add this. So I add this and this. So it's this minus 1 minus 2. That's right, it should be minus 2. But what if I don't have minus 2? What if I'm here? And what if I'm here? What if I'm at this position? Then shall be 0. If they are the same, it's just going to be this. If that's not the same, this is understandable. Now here, I think it's more complicated, right? So plus equal to, we can say if index L is larger than 1. Okay, then we say dpi, well, minus equal to presum index L minus 2. Now if index left is equal to 1, okay, equal to 1, then don't do anything. F is equal to 0, right? If it's equal to 0, then so dpi, we need to add more, add 1 more, like that, right? Like that. If it's larger than, then we need to minus. So here's my understanding that we'll put all of this here as well. Does this work? No, it does not. Gordy, which one? Oh, yeah, we forgot. Oh. If index L is larger than, is smaller than len non-zeros. think I should be more explicit. L if index is smaller than index R, because maybe this one plus one will be the other one will be larger than the other one. Okay. Does this one work? Oh God. Alright, I have to end today. It's way too long. Yeah, I have to end now. I'll think about this again.